Hello. This tutorial will discuss how to complete a measurement with OilWatcher Benchtop, the oil and water analyzer brought to you by Clearview Sensing Incorporated. We'll take a look at sample preparation, measuring the sample, converting the reading to the actual concentration of oil in your water, and selecting cycles per measurement. Samples can be obtained from the sample port on OilWatcher, any sample port on your industrial or process water line, or an open source of water such as a separator, sump, runoff pond, river, or even a puddle of water on the street. A 100 milliliter sample of your water is recommended for easier conversions and to obtain a representative quantity of oil in the sample. Hexane can now be added to the sample in order to extract the oil from the water. 20 milliliters of hexane is recommended to provide enough of a hexane layer for extraction in the case of solids or other matter being drawn into the hexane with the oil. Any amount of hexane can be used though, as long as it's precise and factored into the conversion of the measurement, which will be discussed later. Here we use hexane as the solvent because it's the most commonly used for extraction of oil from water. It's also the solvent used in EPA 1664 oil and grease lab analysis. This ACS reagent-grade hexane is readily available at local chemical supply stores and online. Other solvents can be used though, for example when a non-flammable solvent is desired. Please note that the solvent used for measurements must be the same as the one used in calibration. Please contact Clearview Sensing technical support if help in selecting the appropriate solvent for your application is desired. Lines denoting the sample volume can be seen on the bottle. The sample volume can be higher or lower than 100 milliliters, with the hexane amount adjusted proportionally. If the sample exceeds 100 milliliters during sampling, the entire sample should be kept due to waters with high oil concentration, such as over 200 ppm, having the ability to separate quickly. The water sample with hexane now in it should be shaken vigorously for 2 minutes in order to extract all of the oil from the water and into the hexane. I've skipped ahead to after the sample is prepared. Please note the amount of gas bubbles in the sample from shaking. The sample will now be left to settle before the hexane is extracted. It's sometimes helpful to open the cap of the sample bottle to allow for more of the gas bubbles to dissipate. I've allowed the sample to settle for 2 minutes total. Now I can extract the hexane layer with my 5 milliliter disposable pipette and insert it into a cuvette. You'll see that I extracted some of the additional matter along with the hexane, but that can be squeezed back into the bottle as it settles to the bottom of the pipette. The hexane extraction can now be added to the cuvette. It's a good practice to replace the cap of the sample bottle so that hexane doesn't evaporate during the measurement. The outside of the cuvette can now be wiped clean of any particulate and inserted into the OWB cuvette cell. Please be sure to cover the cuvette cell once the sample is inserted. With the sample inserted into OWB, I can now click Measure to analyze the oil content. On the first measurement of a session, a prompt will ask the user to select automatic labels for the results file in timestamp format, or if the user would like to label each measurement. Next, an info box will come up letting the user know that a conversion will be needed to calculate the actual oil content in the water sample. Our ratio in this case is 100 to 20, so the OWB reading will be divided by 5. OWB will begin taking the measurement. With 5 cycles per measurement, it takes about 2 minutes. With 1 cycle per measurement, it takes about 40 seconds. Accuracy can be slightly increased by using 5 cycles per measurement, but the difference is negligible. I've skipped ahead to the end of the measurement, and now we can see the results given by OWB. Here we can see the 5 measurements taken for this sample. The average is shown to be 439 ppm, which converts to 87.8 ppm by dividing by our conversion factor of 5. Now, let's change the settings to 1 cycle per measurement. This is only for demonstration of the function and to show the slight difference in reading. It is not necessary to repeat measurements with different amounts of cycles during normal operations. With the measurement complete, the fluorescence and transmitted light channels used in the measurement can be seen. One note is to limit retesting of a sample to a few times in order to avoid changes to the sample. If more than a few tests are to be done on the sample, it's recommended to extract a new sample from the sample bottle. Thank you for joining us for the OilWatcher Benchtop measurement tutorial. Please visit www.clearviewsensing.com for more information on products, technical support, and more tutorial videos. Goodbye.